In this video, I introduce you to Python programming. Python is currently available in two versions, 3.4 and 2.7. To download and install Python, you first go to python.org. So you go to python.org, right? And download Python, and it's free. The reason that here I suggest you to download another distribution which is called Anaconda. Is the distribution that you download from python.org may not include all the needed Python packages. So instead, you go here, continuum.io/downloads, and in here you can select the Python 2.7 or 3.4. So first, let's see how Python works. Just like other softwares like R and MATLAB, Python can work as a calculator. For example, in order to use math functions, first you import math module. So you type in import and math and enter. And later on you can use math functions, for example exp for exponential. So you store, let's say you store 2 to the variable x, and then later on give x to the function exp in math module, and then you can show b what you store in b. You can also store multiple values to multiple variables at the same time using one single assignment operators like this. Another way, if you don't want to type in the module name in front of the functions, then you can say from math, okay, from math, and then import star, import everything, import all functions. So later on you can just use exp, for example exp of x, and you don't have to type in math.exp of x. Next, let's talk about operators, data types, and data structures. Python uses many built-in simple types such as integer, int for integer, float for floating point numbers, long for long integers, complex for complex numbers, and strings, etc. And also it uses built-in data structures such as lists, dictionaries, and tuples. Lists are actually dynamic arrays, and dictionaries are associative arrays using key value indices. So you give a dictionary a key, then it gives you the value. And tuples are similar as list but cannot be modified, and sometimes used like structs but indexes by position instead of field name. Operators in Python can be grouped in several categories: arithmetic operators, comparison operators, logical operators, and bit operators. So in the first group, arithmetic operators, you have addition, subtraction, multiplication, division, modulo operator, and integer division. For comparison operators, you have less than, greater than, less than or equal, greater than or equal, and the equality test. And the operators, the comparison operators, return true or false value. For logic operators, you have and, or, not. And for bit operators, the operators are for operations at the bit level. First, let's talk about the first type, which is string. So string is a sequence. String is a sequence of characters enclosed in quotes. First, let's talk about indexing. So here, let's say we create a string containing good morning and store it into the variable greeting. And when you want to, let's say, access to the first character, the first element, then you give the string variable, the index. In this case, it's 0. 0 is the first character, so it returns you the first character, which is G. Slicing. You can also use the colon operator to return a slice of string. So, for example, greeting, and you give it 0 to 4. 0 to 4 means that you take the first character to the character just before 4. Right? So it takes the first, the second, the third, and the fourth. And the index of the first is actually 0, and then 1, and 2, and 3. Right? So you get you give it the index from 0 to 4. So it gets you the slice from 0 to the index just before 4, which is 3. And here it gives you good. You can concatenate strings. So good plus night returns good night. The next type is list. List is a comma-separated sequence of items enclosed in square brackets. So in order to create a list, you use the square brackets. So in the square brackets, let's say I have elements or items A, B, and C. So they are strings. And then if you want to access to, let's say, the first item has the index of 0. Then you type in grade and 0, and this would return A. And if you want to replace an item, one element, then also you do, for example, you store a string containing C plus into the second element. Then you write on the left, you write grade 1. So in the index of 1 means the second element, and then you can show grade, what you have in grade. So you can see B is replaced by C plus. Now more with list indexes. So let's say you have you store a list, and this list contains strings like A, B, C, and D. If you type in grade and 0 to 3, it returns A, B, and C. So it returns the elements at 0, at 1, and 2, right? Just before 3, right? Excluding 3. And if you type in grade and the colon operator number 3 and concatenate it with grade 3 and then colon operator, this returns you actually grade itself here. So it doesn't matter if you have 3 here or other indices. This concatenation would returns you grade itself. And if you don't write anything, for example, just the colon operator and then number 3, then the default is 0. So it's the same as you write 0 to 3, and 3 is excluded. And similarly, if you write 3 and then the colon operator, it's the same as you type in 3 and then colon and then the last element in the list. If you use the negative sign, then the index now starts from the right to the left. So grid -1 would give you the last element, and grid at -2 would give you the second last element from the right. A list can be nested. So let's say you have a list profile containing two elements, John and Grid. Grid is actually another list. You type in the variable profile, and it shows you what it has. So the second element in the list is also another list, and if you measure the length using the length function, it gives you 2. So there are 2 elements, that one and that one. Now look at a list of methods for list. So first, let's talk about append, remove, and insert. So let's say we have the list grid that we created previously. If you want to append an element, then you say grid, then dot, right? And then the append method and the element that you want to append. This is the same as you use another syntax grid, and then on the right you store grid, gonna get the data with a list containing just one element. So if you type in grid, then it gives you what it has. And here F is the new added, the new appended element. Grid.remove. Okay, this is a remove method of the list grid. So remove what? You remove something, then you give the element that you want to remove, and then show what you have in grid. Insert, you want to insert. Using the insert method, you type in grid.insert, and then the position or the index that you want to insert, and the value. So insert F at the position 1, right, or the index 1. This is 0 and this is 1, right? So here you have the newly inserted element. If you want to remove an item at a specified index, then you use a pop method. So pop one would remove the item at the index of 1. So it at the index of 1 you have F, right? So after this you show what you have in grid, then you see there's no more F here. Let's talk more about other methods. For example, extend, index, count, sort, and reverse. So let's say you store or you created grid again, and it has 3 elements now. If you want to, let's say, extend the list to contain more elements, right? So you give it a new list, another list containing D and F, using the extend method. So give it another list. So after running this, you show what you have in grid, and here you can see there are newly added items. You can count the number of occurrences of an item using the count method. So you say grid.count and give it, for example, B. Then it returns you 1. So B appears just once. You can you also use index, the index method, to return the index of an item. So index of D is 3. You can see here, right? 0, 1, 2, and 3. Sort. Okay, sort. You want to sort a list, you just call the sort method, and actually this list is already sorted, so you see the same thing here, A, B, C, D, F. If you want to reverse a list, just call the reverse method and reverse the order of the elements in the list. Now let's talk about tuples. A tuple is a sequence of comma-separated values and can be indexed like lists and strings. So here, for example, here we create a tuple 1 and tuple 2. So tuple 1 contains John, Doe, A. So you can see here is like first name, right, last name, and let's say grade, right, grade, and also another tuple, tuple 2 contains Mary, Hughes, and A minus. Tuples can be nested, so group which is containing tuple 1 and tuple 2, and if you show it, you can see group now contains tuple 1 and then tuple 2 in it. If you want to access to the first element in tuple 1, you say tuple 1 and give it the position or the index of the element, and give you John, right? And if you say group, then 0, and it gives you the tuple in it, which is tuple 1, right? And similarly, this gives you tuple 2. Tuples cannot be modified, so if you try to modify it, it gives you an error here. If you try to modify it, then it gives you an error. Tuples can be sliced and concatenated. So if you want to use the colon operator for slicing, you can do that. You can concatenate tuples together, right? So tuple 1 and tuple 2 make tuple 1, 2, right? Now let's talk about dictionaries. Dictionaries are unordered collections of elements containing key value pairs and indexed by key. So you give a dictionary a key, then it returns you the value, the corresponding value. Dictionaries are mutable, meaning that you can add, delete elements, or change. Have variable lengths and cannot be sliced or concatenated. You create a dictionary using the curly brackets, and within the curly bracket you give pairs of keys and values. So this is the first pair, and that is the second pair, and each pair you have the key, right? Key and value, key and value. So later on, if you ask the dictionary given a key, right, then it returns you the value. For example, here you say roster and give it the key, which is the actually the string containing the net ID. Then it returns you the name, the corresponding name. Values can be actually tuples, right? In this case, you can see. You can use curly brackets, right, to create dictionaries, and you can also use the dict function the same way. And this is actually another way of creating dictionaries. And later on, you type in, let's say, the name of the dictionary, and it shows you whatever it has. Let's look at some dictionary operations. If you want to return a list of keys, then type in roster.keys. Right? This is an array. So it's a list. So using the method keys, you get a list of keys. You can also sort the list of key using sorted. So sorted, and you give it roster.keys, and it returns you the list of sorted keys. You can also check if a key is in a dictionary. So using this syntax, checking if this string, right, JMM 15009 in roster, right, then it returns true. It returns true because it is actually one of the keys, right? If you want to change, so for example, given the key JMM 15009, and you want to store something else, let's say a tuple, right? A tuple with the name and also the grade, but different grade. Then you can do that by giving it the key, right? Giving the dictionary the key, then you can do that. And later on you can show roster, display what roster has, right? And here you have a different grade now. You can also delete a key using the del statement. So del roster and give it the key, and later on you can display a roster again. Then you can see the first pair value the first pair of key values is gone. You can loop through a dictionary using this syntax for example, net ID and profile. So this would be like a pointer, right, for value and for the key and for value in roster dot items, right? And then you can print what? Print net ID and print profile. Right? This is what you see later on. Net ID, right, and profile. Net ID and profile. So this is the keys, and that is the values. Now let's talk about arrays in Python. Arrays are multidimensional. So in order to use arrays, you need to import from numpy. So let's say you import using this syntax from numpy import star, import everything. So later on you don't have to prefix the function with numpy. And later on, let's say you want to create an array, right? An array using parentheses, right? So this line, when it runs, give you an array. This is the first row, the second row, and the third row. And if you want to do matrix multiplication, use a dot function. Dot math would give you the result as an array here. And using this syntax, right, the wildcard, and this would be for element-wise multiplication, so don't be confused. Right? Don't be confused. So in MATLAB, you have this for matrix multiplication, and the dot in front of it for element-wise multiplication. This is MATLAB. So just like MATLAB, you can use functions like sum, like average, like mean, like standard deviation, STD, along with different dimensions. So let's say sum, right? Sum, you can sum math for everything, or sum math 0 for the first dimension. So if you sum this and it sum along the first dimension, then it gives you a row, which is an array, right? A row. So 12 would be the sum along the first column, and this is sum for along the second column. This is the sum along the third column. If you say sum math and 1, then this sum along the second dimension, just like in MATLAB. But in MATLAB you use 1 and 2 instead of 0 and 1. So it gives you, for example, 6, which is the sum along the first row, the sum along the second row, and the sum along the third row. Average and mean and STD work in the similar way. Now we talk about matrices. Matrices are rectangular tables of data of the same type. So just like with arrays, you need to run this line first from num py import star, and then if you want to create a matrix, you do it the same way, follow the same way, just like with array, but instead of array you use matrix, right? So you have to first row, second row, third row, and it's just similar as with arrays. You can do matrix multiplication. You can also use dot function, and similar, just similar as with arrays. You can use sum, mean, STD, along with different dimensions, just like with arrays. And you may notice that the result from functions like mean, standard deviations, STD, sum, etc. are matrices, not arrays. Now let's talk about control structures in Python. This is the if statement. So we have if and branches. Using if, you have multiple if, and finally you may have else. And you may notice that after the condition you have the colon. Let's look at the example code. Let's say you store 1 to the variable x, and then you run you can either copy this code and save it as a file and run the file, or you can just copy the code and paste to Python and run. So if x is less than 0, then print something, right? Print the string negative. And if it is equal to 0, then print 0, and else print positive. Let's just run this, and notice that now there is equal indentation for all the print statements here. This is the result, right? This is the result, and this is positive. So x, the value in x is 1. So the first condition is not met, right? And you go to the next, it's not met as well. So finally you go into else and say and print out positive. Now let's look at the for loop construction. For a variable in a sequence, then do something, and notice the colon at the end. Here let's look at some example code. So for a variable I in range 3, so range 3 would returns numbers like 0, 1, and 2. So it range returns give you some numbers starting from 0, progressively increase to the number just before the number 3 here. For example, if you give it n, then the last number would be n minus 1, and the result is a list. So here you loop for each element in the list and print the element, and at the end, after each print, after the print command is executed, then you print a space. So here you can see print 0 and then the space, and 1 and a space, and 2 and so space. Here are some other variations. Right? So you say range 1 and 3, then it will return just a list from 1 to 2, and that's it. And range, and you give it 1, 6, 2, then it returns you 1, 3, 5, right? Basically, this is a step, right? From 1 to 6, actually from 1 to before 6. Another loop structure is while loop. The while condition is to true, then do something, and remember this. Remember the colon. This is an example, right? While x is less than 5, then do something. So actually, before that, x was assigned to 1. That was actually from the previous slide. So while x less than 5, and the condition is met, right? Because x has 1 in it. Then print x, and then after printing x, you also print the space, and then increase x by 1. So finally, it print 1 and then space, and then 2 and then space, etc. 3 space and 4. Let's talk about functions in Python. How you can write your own functions. Right? We talked about modules and packages in Python as well. In order to define your own functions, use this syntax: right? Def and the name of the function, and then the parameters, the colon, and in the next line you start the body with some indentation here. Let's look at this example code. Here you define a function, namely square, right? Using def, the keyword def for define, and there is one parameter x, and also you remember this, remember the colon, and then go to the next line with some indentation. Right? You store x times h to y and return y. And later on, when you call the function, you call the name of the function and give the parameter to it, and you give it 2. The value returned is 4. The parameters are passed by value, and only the local copies are changed. And mutable objects, for example, lists work like reference parameters. So let's look at this example. Here you define a function, namely list_add, and give it. There are 2 parameters, 2 arguments, and here is actually the length of the list. And now you have a loop for each element in a list created by the range function. So range n would give you a list from 0 up to n-1. So what you do is you add that number to every element in the list, and later on when you call the function, let's say you create a list, namely a list, right? And a list contains 1, 3, and 5, and then call the function list_add, give it the list, which is a list, and the number here, which is 2. Then the number 2 is added to every element of the list, and later on if you show the list, then you see 3, 5, and 7. So basically that is the way that you can use passing by reference. Now let's talk about modules. Any Python file is a module, and its name being the file's base name without the .py extension. So let's see how we can create a module in Python. We create a module and we store the code in this file. Let's say mymodule.py, and we write the code in there. And in this file, it contains this function, right? Cubed, and that's one parameter, and it returns actually x cubed. So now we try to run this. So first I want to import the module, and the module is stored in this folder. So first I have to import sys and then append this path so that the system know where my files are, right? Where are my modules. And then later on I can say import my module. Once I have this, then I can call the function cube, right, and give it 6, right? And it returns me some result. And I have to prefix the function by my module, right? Another way that allows me not to use not to prefix this is to say from my module import star, right? We talked about that before. And modules contain their own public and private variables to prevent conflict with variables in others. Now let's talk about packages. A package is a collection of Python modules, and you can go here. You can go to this link. It contains the Python package index with Python packages. Now let's talk a little bit about Python I/O functions. In Python, in order to open a file, use this syntax. Right? Use open function. If you want to open a file and to read, use the parameter R, and otherwise, if you want to write, use W, and also give it the file name. And to close files after reading or writing, use a close method. Now let's see how we can read a file. So with the variable, the file variable, and you call the read method, it returns the remaining contents of the file. Read line and read lines also very useful. So read line return the next line, and when you get through some lines and you say read lines, and it returns the remaining. To write the file, you say the file variable and then call the method write, and the string to write to the file. This is an example. So I have a file. Actually, this is a module, namely my package.py, and I want to open this file for reading. And then for each line in the in file is a file variable. Then I get a string. I read a string from the file and store it in a string, and then print a string. This is another example for opening a file and writing to the file. So you use the W parameter as a second parameter, and also give it the file name to write as the first parameter. And you write what? You write just a string test. For handling Microsoft Excel files in Python, you can use XLWT package and XLRD package. For Python functions, you can check out the links for Python 2 and 3. Now let's talk a little bit about graphical functions in Python. So in Python, you can use pylab and pyplot. modules. Right? So PyLab and pyplot modules in this package, in the matplotlib package. So in order to import, let's say import PyLab, you say import matplotlib dot pylab, right? And as plt. So later on you just use plt as alias. And also if you want to use pyplot, use a similar syntax, import matplotlib dot pyplot and the package the module as ppl. Let's look at this example. Right? Import matplotlib dot pylab as plt. Right? So later on you just use plt as a prefix. Right? So plt dot linspace. So you call the linspace function in the plt module and give it 0, 10, and 100. So it gives you the list with starting values 0 to 10 with 100 values and store it in x. Then you compute x power to x squared actually, and then store to y, and then later on call the figure function to start a new figure, and then plot y against x using the blue color, and give it x label, the y label, the title, and show it just like you do it in MATLAB. So we will do some more examples regarding Python programming, and for now just show the code that we have in the lectures, and happy coding.